Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from summer 2023. This paper is worth 120 marks in total, and this is the second video of 6. It will focus on questions 5 to 8, which account for 23 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 5a, solve 7x subtract 5 equals 2x add 3. So 7x subtract 5 equals 2x add 3. The only reason I'm writing that equation out again, guys, is I like space to show my steps and working out. So we have an equation to solve where the unknown variable x appears on both sides. So what I'm going to do is I'm going to eliminate the smallest term, the smallest x term, okay? So we've got 7x and we've got positive 2x. I know that that's a positive 2 because there's no negative sign in front of it. So if I compare 7x and 2x, 2x is the smallest x term. So that's the one I'm going to eliminate. So to eliminate positive 2x, I need to take away 2x. So when I take away 2x from the left-hand side, 7x take away 2x is 5x. I've still got that minus 5, didn't do anything with that. When I take away 2x from the right-hand side, 2x subtract 2x is 0, so that's what eliminates it, and I'm left with that positive 3. I've now got a two-step equation, so I'm going to eliminate the negative 5. Remember, I'm aiming to solve for x, the unknown variable, so I want it to end up being x equals, so I'm trying to isolate it. So I'm going to eliminate the subtract 5. The opposite of subtracting 5 would be to add 5. So 5x, negative 5 plus 5 is 0, so that's what eliminates it for me. And then I need to do the same on the right-hand side so that I'm balancing the equation. 3 add 5 is 8. Now we're working with a one-step equation. 5x is 5 multiplied by x. The opposite of multiplying is dividing. So to get x on its own, to isolate x, I'm going to divide by 5. 5x divided by 5 is x. I need to do the same to the right-hand side. 8 divided by 5, well, I'm going to write it as 8 over 5. Now, when I look back at the question, it doesn't ask me to give my answer as a fraction, a decimal, etc. So I'm just going to leave it like that. It's accurate. And it's just remembering the fact that a fraction is a division. Part B. Rosa is buying bananas and apples. She buys X bananas, which cost 30 pence each. She buys 2 more apples than the number of bananas she buys, and her apples cost 25 pence each. She pays a total of £5.45. Use an algebraic method to find the number of bananas Rosa buys. So we're using an algebraic method, so we are going to have to form some algebraic expressions, potentially even an equation, and solve it. So let's start with an expression for the number of bananas. Okay, so the number of bananas that she buys is x. But then they tell us that the total cost is 30 pence per banana. So we can also write an expression for the total cost of bananas, which is that 30 pence multiplied by the number of bananas, which is x. Okay, let's form an expression for the number of apples that she buys. So it says she buys 2 more apples than the number of bananas. Okay, so if the number of bananas is x and she buys 2 more apples, we can write that as x add 2. So now we can form an expression for the total cost of apples. So it tells us that apples are 25 pence each, so the total cost would be 25 multiplied by the number of apples, which is x add 2. Now I'm going to expand that bracket now. So 25 multiplied by x is 25x. 25 multiplied by positive 2 is positive 50. Okay, so the next piece of information they give us is the total that she spent. So that would be the total of the cost of bananas and the cost of apples. So we can now form an equation. So the total cost of bananas plus the total cost of the apples must equal £5.45. Now these are all working in pence, So I'm going to work in pence for my calculations as well, because working with 545 will be a little bit simpler than 5.45. So that's 545 pence there. Now I'm going to collect like terms to get myself to a simple equation that I can then work with and solve. So 30x plus 25x is 55x. So 55x add 50 is 545. So we've got a two-step equation here. So I'm going to eliminate that add 50. Remember, I'm trying to isolate x so I can solve it, because x is my number of bananas. So I'm going to subtract 50 from both sides, because the opposite of adding 50 would be to subtract 50. So when I subtract 50 from the left-hand side, it eliminates 50, because 50 subtract 50 is 0. When I subtract 50 from the right-hand side, 545 subtract 50 is 495. Now we've got a one-step equation. 55x is 55 multiplied by x. The opposite of multiplying by 55 would be to divide by 55. So 55x divided by 55 is x. So I've isolated x. I've got x on its own. I now need to do the same to the other side. So I'm going to do 495 divided by 55, which is 9. So Rosa buys 9 bananas. Okay, part C, factorise x squared, add 5x, add 4. Okay, so when we're factorising this equation, we want to put it into two brackets. So we want it to look something like this. The reason why I know I'm factorising into two brackets is because I've got a squared term and a constant number term. It doesn't matter about this thing in the middle, but if I have a squared term and a constant number term, it needs to be two brackets, because I need x in each bracket, because the x multiplied by x, if I was to expand, would give me x squared. But then I also need two numbers inside the bracket that multiply together to give me the 4. So that's where I'm going to start. I'm going to think about two numbers that multiply together to give me 4. So I can have 1 and 4 or 2 and 2. Okay. The next step we need to consider is those two numbers that multiply to 4 also have to add to give me 5 in the middle there. So 2 plus 2 is 4. That's not going to work. 1 plus 4 is 5. So I'm going to use 1 and 4. And they're both positive, which makes my life nice and easy. Question 6. Heath has £3,000 to invest for 5 years. No extra money will be paid in or withdrawn during these 5 years. He's going to choose one of these accounts. So he can choose account A. So account A has 4% compound interest per year. The interest rates can vary. Okay. Account B has a guaranteed interest at the end of the 5 years of £190 for each £1,000 invested. So part A asks us which account gives Heath the greater percentage increase in his money at the end of the 5 years, and by how much is it greater. Okay, we've got to show how we decide and state any assumptions that we make. So if you look at the bottom here, we're identifying the account that gives him the greatest percentage increase, how much greater it is, and any assumptions that we've made during these calculations. So the first thing I'm going to do is I'm going to calculate how much interest he would earn in account A and account B across those 5 years with that £3,000. So account A. So he's investing £3,000 with a 4% compound interest rate for 5 years. So we're going to use our compound interest formula. So we're going to do £3,000 multiplied by, well, we're doing an increase of 4%. So that would be a multiplier of 1.04. Because if we're increasing by 4%, that's 104%. 104 as a decimal. 104% as a decimal is 1.04. And then we raise that to the power of the number of years. So he's investing it for 5 years. So I'm going to pop that into my calculator. So 3,000 multiplied by 1.04 to the power of 5. So that is 3,649.99. It's 958,707, but we're working with money here, guys. So I'm going to round it to 2 decimal places. So that's how much he earns. I'm going to now check what that percentage increase is, because we're looking for the greater percentage increase. So to check the percentage change, we do the difference. So the difference from the original to the new, which is £649.99. Divide it by the original, and then we times it by 100. So 649.99 divided by 3,000 times 100. So that's 21.66%. So I'm going to say that's 21.7% increase. Okay. Now I'm going to do the same for account B. And I can't write. Okay, so account B, they get a guaranteed interest at the end of the 5 years of £190 for each £1,000 invested. So we're going to divide 3,000 by 1,000. So there's 3 lots of £1,000 invested. So at the end of the 5 years, he would have 3 times the £190 that they mention here. So 3 times 190. So you'll have £570 interest. I'm going to find out what that percentage increase would be. So the difference is £570 because that's the interest he's earned on top of the £3,000. The original is £3,000 times it by 100. So I've left 570 in, so I'm going to divide that by 3,000. And then I'm going to times my answer by 100. Notice I didn't times by 100 all in one big row because calculators do weird things. Okay. 19%. So account A gives the greater increase. 21.7% is greater than 19%. So I'm going to pop account A there. But we need to know what the percentage difference is. So we're going to do 21.7 subtract that 19%. We're just checking the difference between the percentages. So 21.7 subtract 19, which is 2.7%. So it's a 2.7, it's greater by 2.7%. Now we've got to talk about that assumption that we made. So the assumption is going to be based on this fact here, because for account A, it says that interest rates can vary. Okay, so the assumption that we've made is that the interest rate does not vary across the 5 years because we've used 4% for the whole 5 years. So the assumption is that the interest rate on account A does not vary during the 5 years. Okay, part B. Comment on the effect that your assumption in part A has had on your decision. Okay, so the effect it's had is that actually, if the interest rate does vary, but the interest rate's higher, then the percentage difference would be higher. But if the interest rate lowers, then the percentage difference could actually lower. So what I'm going to comment here is, so if the interest rate does go up for account A in those 5 years, it's still going to be the account that gives the greater percentage increase, okay? It's just this value that would change. However, if it's lower, it could potentially not be the account that gives the greater percentage increase. So I'm saying my answer could be wrong. So it could be wrong if the interest rate lowered enough in the 5 years. Because if it lowered enough, it could change my answer. B could have the greater percentage increase, couldn't it? Question 7. So the diagram shows a small park with gates at A, B, C and D. So A, B, C and D. The scale is 1 centimetre represents 10 metres. So we're dealing with a scale drawing here because obviously a park is massive in real life and we can't represent that accurately as it is on a diagram without scaling it. So we've got our park there drawn for us. Our scale is repeated here. Really important to remember that. So a new outdoor gym is to be built in the park. this gym should be at least 55 metres from the gate at A and nearer to the gate at B than the gate at C. So at least 55 metres from A and nearer to B than C. Use a ruler and a pair of compasses to show accurately on the diagram the region of the park where the outdoor gym can be built. Indicate clearly the region that is your answer. Okay, so this is a loci and constructions question. And we're working with a diagram here. They've given a scale 1 centimetre represents 10 metres. They've given us this distance from gate A in metres, so we need to convert that to be in centimetres. So 55 metres divided by 10 metres would give 5.5 centimetres because every 10 metre is 1 centimetre. So we're going to construct a region that is 5.5 centimetres from gate A. Now this criteria here only mentions gate A, so it's from a point. So when we're doing the locus of points from a point, it's simply a circle around that point. So we're going to set our compass to 5.5 and then we're going to draw an arc. You can draw a full circle if you want, but we're only interested in the part that actually intersects with that diagram of the park, so this is why I've drawn an arc. So every point on that arc is exactly 5.5 centimetres from A, okay? Every point inside that arc is less than 5.5 centimetres from A, and every point outside that arc is greater than 5.5 centimetres from A. So that's points to note. The next criteria is they want it to be nearer to the gate at B than C, so nearer to B than C. So we're working with a locus of points between 2 points. So for this, we're going to construct a perpendicular bisector. So you need to put your compass on one of the 2 points that you're perpendicular bisector in and make sure that you go over halfway. So set your compass over halfway and then you're going to draw an arc from the 1 point, leave your compass exactly as it is, and then draw your arc from the other point. So both arcs need to intersect, which is why we set our compass to be over halfway between them, because that was going to guarantee that our arcs would intersect. So now that they intersect here and here, we're going to draw the locus of points that are equidistant from B and C. So that perpendicular bisector, what it does for us, it not only forms right angles here and bisects B, the line B to C in the middle, it gives us a locus of points that are all exactly the same distance from B than they are C. And I know it doesn't look that way because of how the shape of the diagram, but trust me, everything on that line is the same distance from C that it is from B. So now we've constructed the 2 criteria that they've mentioned. We're not going to rub any of this out because your construction lines go towards marks, guys. If your examiners can't see those and you mark the wrong region in the end, you're going to lose all of your marks. So do not rub them out. Okay, so we want this gym to be at least 55 metres from gate A. So it's got to be on the arc or past it. On the arc as a minimum, okay, because that's exactly 5.5 centimetres, 55 metres. But it also has to be nearer to the gate at B than the gate at C. So this line is our midpoint of BC. So we're looking on this side of the line and outside of the circle. So I'm going to highlight our area. So we want to keep closer to B. So we're going to be on that side of the line, but we want to be on the arc or beyond it, because it wants to be at least 55 metres from gate A. Well, that's our 55 metre point, so that's the minimum it needs to be. So everything else beyond that point is also acceptable. Now, I'm using a highlighter so you can see nice and clearly. You could simply shade in pencil, just in case you shade the wrong region and you want to rub it out. Even if you shade in pencil, I know you're going to cover those construction lines, but they'll see all of these other ones, so they'll know that you've done it correctly. Question 8. So we've got a diagram here with an aircraft and a right angle triangle formed. The diagram's not drawn to scale, so it's really important to remember that we can't measure anything directly from that diagram. So an aircraft is making its final approach ready to land. The aircraft is flying at 3 degrees to the horizontal, and they've marked that on the diagram for us. So it's flying at 3 degrees to the horizontal, and it's 2.5 kilometres horizontally from the start of the runway. Again, this is the position of the airplane, and it's 2.5 kilometres horizontally from the start of the runway. And it's all shown on the diagram for us. Calculate the vertical height of the aircraft above the horizontal ground. So if we're calculating the vertical height above the horizontal ground, then the bit that we're interested in is this part of our right angle triangle. So that's what we're looking for, okay? So we're dealing with a right angle triangle. We've got some angles. We've got a 90-degree angle here, but we can also calculate this angle here. And the reason why I need to calculate that angle is I've got to use trigonometry. I can't use Pythagoras' theorem on this right angle triangle because I've only got one of the lengths. So it's going to have to be trigonometry. But to work with trigonometry in right angle triangles, I need another angle identified inside that right angle triangle in some way other than the 90-degree angle. So we are 3 degrees to the horizontal. This horizontal is a 90-degree angle. So 90 subtract 3 tells us that that angle there is 87 degrees. So now I have a right angle triangle. I'm going to use trigonometry to find the side that is X. So let's start by labelling our sides. So the opposite side is always opposite the other angle. The hypotenuse is opposite the right angle. And the adjacent is next to the other angle, or the side that we haven't yet labelled. So for this question, we've been given the opposite side as 2.5. We're looking for the adjacent side. So we're working with the opposite and the adjacent. So the trigonometric ratio that we need to use is the tangent ratio, okay? So tan is the opposite divided by the adjacent. So tan of that angle 87 is the opposite, which is 2.5, divided by the adjacent, which is our X value that we're looking for. Okay, so you can at this point either solve that equation using inverses, or you can use the one of the SOHCAHTOA triangles. So we're looking for the adjacent side, so if we cover that up, we're doing the opposite divided by tan, okay? So X equals the opposite, which is 2.5 divided by tan 87. And I'm going to pop that into my calculator. So fraction 2.5 divided by tan 87. Close your bracket just to be safe because it'll automatically open one when you put in sin, cos or tan. So it is 0.13101944482. And I know that looks like a strangely small number, but we're working in kilometres here, guys, so it's actually not as small as you think it is. So I'm going to put kilometres on the end. Doesn't tell me to round it in any particular way, so I'm going to leave it like that.